Hi, my name is Marc Sweetgall. I'm a program manager at Microsoft, and I'm here to talk today about building apps for Windows 10 on ARM. In this session, I'll be going over the benefits of Windows 10 on ARM, talk about the details of supporting Windows 10 on ARM, go into a little bit of how to get started, show a quick demo of building an app for Windows 10 on ARM, and then talk a bit about debugging and testing and the next steps to take. So Windows 10 on ARM, or Always Connected PC as we talk about it sometimes, is an opportunity to delight Windows customers. We think of it as bringing the best from your phone into your laptop or two-in-one. And that results in these kind of key points below that really are the highlights of the platform. And the first one, which is one that I cannot stress enough, is that these devices are just Windows. They come with Windows 10 pre-installed, they support Home, Pro, Enterprise, whatever you need. And it's not some limited or locked down version. It's the full Windows experience. It's exactly what you'd expect from a Windows device. But because of the marriage of Windows and the phone, you really get this amazing battery life thanks to the ARM processor that's in there. To the surprise of no one on this call, ARM processors are well known for both battery life and performance per watt. And so these devices, we've been seeing ones that get over 24 hours of battery life, which is just unbelievable. For me, as someone who used to, I would pack extra batteries on a laptop for a laptop on a plane and then hot swap them in on the flight if it was longer than a couple of hours. I really don't miss that. In fact, when I first started with Windows 10 on ARM and I had my first device and I was using it, I realized that I wasn't bringing the charger home anymore. I would actually bring the laptop home over the weekend, use it on our off Saturday, Sunday, and then bring it back to the office on Monday and plug it in. And it just happened so slowly I didn't even notice. But the amazing battery life that the device had really changed my perspective on how to use a device and what it means to be, tethered to the wall. And then another feature of phones that you don't think about as much with laptops is LTE connectivity, speaking of tethering. These devices all have LTE, which is no surprise. These are Qualcomm Snapdragon chips. They have LTE on the chip. And if you've never had the opportunity to use a laptop or two-in-one with LTE connectivity, it's really worth a try. It's just a great experience and very freeing to be connected wherever you are, no matter what. And you can do that without using up your phone's data plan, or in my case, my phone would get really hot if I try to tether to it, and it's nice not to have to worry about that. It's just connected. You open the device, it's been up to date the whole time. And in corporate settings, you can imagine using dedicated LTE is attractive compared to if the alternative is maybe using coffee shop Wi-Fi or unprotected hotel Wi-Fi. And so it's great from a security perspective as well. And then the last point I want to talk about, when thinking about phones, you pick it up, it's just on. You don't need to worry, you don't have to wait for it to come back from sleeping. It's on. And it's almost weird that we've allowed laptops to not have that feature. And so this is something that these devices all come with. You open the lid and it's just on. It's ready to go. It's up to date because of the connectivity. And it has battery because of the battery life. And you're just ready to go. I mean, why wait? And then as an extra bonus, because these devices are, since the chips are also small and have low power requirements, this provides our OEM partners a ton of flexibility in terms of the devices that they can create. As you can see here on this slide, we have 9 different devices in market across 3 different processor generations in these waves I've illustrated here. And they come in a variety of different form factors. All of them are thin and light, and none of them have fans. So you can see our journey. We've started with the SD835 on the left, the Snapdragon 850 in the middle, and then on the right you have the latest and greatest, the devices running the 8CX processor from Qualcomm. On the top right, the Samsung Galaxy Book S, which I'm particularly partial to because that's what I'm running this presentation from. Via the bottom, the Lenovo, the Yoga 5G. And then in the middle, the Microsoft Surface Pro X with the SQ1 processor, a close relative of the 8CX. And actually, since this slide was written and locked down, Qualcomm has announced the 8CX Gen 2 platform. And those processors will be coming to market soon with devices as soon as this year. But let's talk a bit more about the software. This has all been hardware. The software is really why we're here today. And I'm going to start with kind of a bold assertion that Windows 10 on ARM can run your app So Windows in general, and therefore Windows 10 on ARM, runs both Win32 apps as well as universal Windows apps, modern apps through the store. On the Win32 side, Windows, to the surprise of nobody, has an extremely rich, varied history and ecosystem of Win32 apps, ranging from small console apps to massive productivity suites and business essential apps that cost millions of dollars. It's a wide range in Win32. But on Windows 10 on ARM, x86 apps run as is without any sort of modification, thanks to emulation layer. And this provides a great set of apps for users to use from the beginning, even if the developer is unaware that ARM exists and has never known ARM exists. I will call out that we don't emulate drivers, and so drivers need to run as ARM64 native. But the tools are out there for developers to build their drivers as ARM64, and apps that rely on drivers aren't as common as you might think. In fact, we are so confident with x86 emulation that we recently announced that we are expanding the Aperture program so that enterprise and commercial customers who try out Windows 10 on ARM and hit some sort of compatibility issue can get those fixed. We'll actually work with them and the ISV and get that app working on ARM for free. That's how confident we are in the x86 emulation. And yet, emulation is only part of the story. The platform really shines when you talk about ARM64 native apps. If developers have rebuilt their app for ARM64, the resulting product is the performance, the responsiveness, it's eye-opening. It really unlocks the full power of this chip. And so I've called out Edge and Firefox and Visual Studio Code because all of them have ARM64 native versions. And if you spend a lot of time in those apps like I do, you'll notice that the experience is just buttery smooth. It's really, really nice and something to try. On the other side of the house, apps provided through the store continue to provide a trusted method of delivery. You know exactly what you're getting. It's coming directly from Microsoft. Unsurprisingly, x86 apps run as is under emulation through the store, just like with Win32. Through the store, there's both ARM, referring to 32-bit ARM or ARM32, and ARM64 apps. Both of those can run with native performance from the store. Now let's say you want to support Windows 10 on ARM. It's good to first think about what you want to do for each of the components in your app and which ones you want to build as ARM64 and maybe leave as x86. And so I've called out three categories here. On the left, you have some things that really need to be built for ARM64. Drivers, of course, as I mentioned before, must be native. So if your app depends on a driver, you need to rebuild the driver as ARM64. If any of your code needs to run in process with an ARM64 process, let's say like Explorer, if you inject into Explorer, that code will need to be ARM64 as well. And then if you have really heavy-duty, performance-sensitive code, CPU-intense things, you want to rebuild those as ARM64 as well, so that the customer has the best experience. It'll be faster, and it'll also impact the battery less as a result. But in the middle, you have a choice. We always recommend running natively, but it's not all or nothing. So long as you haven't put a lot of heavy CPU loads into the UI, you could leave the UI as x86. There's nothing wrong, for example, with having an x86 UI and an ARM64 driver. After all, that's what OpenVPN does today, and that works very well. And then there are other bits that you would, if you have a user mode service or a web service that is in the background, if that's not running heavy-duty perf-sensitive loads, those can also stay as x86 because the user isn't really interacting with them and may not notice. In fact, if your whole app doesn't do very much in the CPU-intense space, you could leave it all as x86 and then maybe over time upgrade components to ARM64 as you see fit. Then on the right, you have components that you would want to keep as x86, and mostly for compatibility reasons. Windows 10 on ARM comes with an x86 version of Internet Explorer. And so if you are, in 2020, still building ActiveX controls for Internet Explorer, you'll want to make sure those are x86. And then if you have any software that needs to run in the same process with an x86 process, maybe because it runs in Internet Explorer or in other software that hasn't been ported to ARM64, you'll need to make sure that that code is x86 as well. And then if you have a common bootstrapper, which is a common platform that or a common paradigm that we recommend, if you have a bootstrapper that installs the right architecture on different platforms, you'll want that bootstrapper to run as x86, because then you can have one bootstrapper that runs on 3 platforms, x86, x64, and ARM64. All of them, it would work. With that in mind, here's a summary of kind of the effort that you would need to build each class of app as ARM64, keeping in mind the previous slide. So for universal Windows apps, those are frequently a checkbox away from building as ARM64. Frequently it is zero work, and I know that sounds like hyperbole, but we've seen it happen. You hit the checkbox for ARM64, you hit build, and you have an ARM64 app. Wow. For Win32 desktop apps, either shipped standalone or through the store via Desktop Bridge, the action is going to be to recompile as ARM64, at least the pieces that need to be ARM64, as we talked about before. And that's frequently a small amount of work. I'd love to say it's zero, but it's usually a little bit, because there's 2 things that come up, mainly dependencies, which we'll talk in depth later, and assembly code. If you have assembly code, it's going to be architecture specific, and so you'll need to either port that assembly to ARM64 or rely on something like a C fallback and then build that as ARM64 with the compiler. And then if you have a .NET-based Win32 app, today that runs as x86.NET on ARM64. And that may be fine for what you're doing. But if you want to build as ARM64 to get the best performance out of that .NET app, you'll need to move to .NET 5 when it's released later this year in order to get full support for ARM64. But now that we've talked about scoping the effort, let's get started with building. And so the first thing you're going to want to do is make sure that you have updated tools for building ARM64. It should be no surprise that MSVC supports ARM64 targets. And that support was added in Visual Studio 2017 version 15.9 and obviously continues in 2019. You'll want to make sure you've added ARM64 individual components as needed, and thankfully the Visual Studio installer experience now has a search bar, so you can type in ARM64 and just pick the ones you need. Much easier than before. And I do want to reassure you, and it should be no surprise based on what you've been talking about, but using the MSVC tools, you can build both store apps and Win32 apps as ARM64. I know we have a history with that not being the case on other ARM platforms that I won't really talk about, but in this case, it's a totally open platform. MSVC, you can build both Win32 and UWA, no problem. And then I'll add one more plug for Visual Studio Code. If you enjoy the local dev environment and local dev experience on an ARM64 device, using the native Visual Studio Code is going to be fantastic. You can also run Visual Studio proper as an emulated x86 application. That does work, and you can just hit F5 and do debugging, whatnot. It's really up to you, either way. But we have some pretty big fans of Visual Studio Code, which is a big part of why it's now building as ARM64, thanks to that community enthusiasm that really pushed it over the finish line. And if you don't use MSVC, that's not a problem. We support ARM64 even in Clang and LLVM. That's what's used to build ARM64 Chromium and ARM64 Firefox today. And those are pretty big projects. But with the tools in hand, we should talk more about dependencies. Far and away, the number one issue that we hear about when people are trying to build for ARM64 is dependencies. And to put it simply, your project itself is likely very easy to build as ARM64, but you will need ARM64 versions of your dependencies. And how you approach that depends on where those dependencies come from. Of course, in-house dependencies are arguably best case. It's your code. You can go reach out to the team within the company, or maybe it's your own team, and have that project get built as ARM64 as well. If you have a third-party dependency, you would need to reach out to that ISV and ask for ARM64 support. But you might be surprised to find that you're not the first person who's asked. Obviously, as the platform has gotten more mature, we've had more and more people trying to build their apps as ARM64, and you might find that the ISV has already been looking into ARM64 support. They might have a closed beta that they're testing. It's worth a shot. If your dependencies are open source, you can look to see if someone else has already added ARM64 support to it. And if they haven't, it is open source. You can consider adding ARM64 support yourself. That's the beauty of open source. And then finally, one thing we do hear about every once in a while is out-of-date dependencies. Let's say you have a dependency that was last updated in 2015 and it's frozen in time. At that point, there was no ARM64 Windows. So how could there be ARM64 support? But it might be time to replace that dependency entirely. If you think about what happened if there was a security issue in that dependency, you wouldn't be able to update it to fix that. And so it's hard sometimes to move off of dependencies that you're no longer, that are maybe out of date and no longer maintained, but it's important from a project level to do that. And so as a side benefit, if you make that move, you can get ARM64 support and make it that much easier to build for ARM64. But in general, the ecosystem has been making great progress toward building ARM64 and having ARM64 support. Projects big and little are building ARM64 thanks to efforts from the community, from engineers at ARM and at Microsoft, everyone. And so I call out a few major projects here. You might recognize their logos. We have ARM64 versions of Chromium, of V8, of Electron, Node.js, and Ceph in particular. Obviously, there are lots of other projects as well, but these are some big names that were major hurdles for people in the past. And so having support for ARM64 makes it that much easier for other developers to in turn support the platform. And maybe the next layer of dependencies is getting built. You might need to update your project. For example, with Electron, you need to update to at least one of the 6.0 revisions or later. But at this point, you needed to anyway. And while we're talking about dependencies, I can't really skip adding in a plug for VC Package. VC Package is a one-stop shop for any of your dependency libraries. It's a C++ package manager on GitHub with over 1,000 libraries, at least maybe 1,300 now. The community adds new libraries all the time, as well as updates existing libraries to keep them up to date, and then patches. And so you'll see patches get added to fix issues in libraries that haven't yet been moved upstream. And sometimes those patches add ARM64 support even before the library is ready to declare that they have it. And so that can make things a lot easier if you're building for ARM64. And so you can get VC Package on GitHub, github.com, Microsoft VC Package. And then once you have it installed, you can install various dependencies just by VC Package install, the dependency name, and ARM64 Windows, for example. All in all, getting dependencies sorted out might sound like a lot, but it's definitely gotten a lot easier. And another piece that I want to highlight as having gotten a lot easier, because it used to be a big blocker, is actually installers. When we first released the tools for building ARM64, it was really difficult to then take that built app and put it on customer systems. And so we've gotten a lot better about it. And there are now a bunch of supported platforms for distributing your ARM64 apps. Obviously, apps for the store, those packaging formats all support ARM64, AppX, AppX Bundle, MSIX, what have you. On the Win32 side, we support ARM64 MSIs, and we also support a number of various bootstrappers that will be able to install the right flavor of ARM64 app. And I've called out a few of these bootstrappers here. You have Wix, which has added support for ARM64 with the latest build, version 3.14. You have NSYS, InnoSetup, Squirrel, which added support recently with version 2.0, Advanced Installer, and Installaware, which was one of the first to support ARM64. All in all, it's a great time to be building your app for ARM64. And you might be asking, okay, well, what about issues that only happen on ARM64 or other ARM64 specific guidance? And the fact is, there really isn't a lot. The fact is, Windows is just Windows. If you can build code for x64 Windows, you could build code for ARM64 Windows. It really isn't that different. And so let's take a look at building an app for Windows. Most of the time, when I do demos of building for ARM64, I start with Visual Studio, installing the right components, hit build, so on and so forth. But in the spirit of ARM DevSummit and knowing how much effort ARM has put in specifically to getting Electron to build for ARM, let's show building an Electron app for ARM64.
Wrap my head around Electron. I stumbled upon Electron tutorial app. I found it to be a great tutorial, but by now it's a little out of date since it was last tested with Electron 5. But now let's try building it for ARM64. Here I have an ARM64 Node.js, as you can see. I'll clone the repo for the tutorial and CD into it. And if I try to build now, it won't work because the Electron version is too low. So I'll do a quick edit to the package JSON to bump the version up to 9. And that's it. I can run npm install and have it build. Success. I could run the app through Electron now. Since I want to see it in a more redistributable form, I can run Electron Packager and have it spit out an exe. Now that it's complete, we can check the exe with dump bin to see that it is in fact ARM64. Success. I'm going to try it out. It works, it launches. I can open a second window, show an error message. What more could you want? But maybe you have a more complicated project, like one with a native module. The good news is those work as well, as you can see when I install Keytar. Sure enough, the ARM64 version of Keytar.node successfully builds. Now this was all with the ARM64 version of Node. But let's try something different. This is x86 Node, as you can see. Thanks to the work of the open source community, our friends at ARM, and engineers at Microsoft, cross-compilation for ARM64 Node also works, so we'll give it a shot. I'll switch into the project directory from before, and then clear out everything that was built earlier just to keep it simple. Then the key is just to set the npm config architecture to ARM64. And at that point I can do npm install and do the Electron packaging as ARM64 as before. Now, the real value of cross-compilation comes from being able to use a beefy x64 machine to build your ARM64 code. But it is fun to see it able to run successfully under emulation. And it's done. Now, it definitely wasn't as fast as using the ARM64 native version, but in the end the result is the same, including the native module that I'd saved before as a dev dependency. If we kick it off, there it is. And so that's an ARM64 native Electron app built with x86 Node.js running under emulation on an ARM64 Windows device.
And thanks, of course, to Christian for that app and that tutorial. Very helpful. But so let's take us home and talk about debugging and testing. So you have options when it comes to debugging. Debugging through Visual Studio is usually our recommended approach, and in particular, remote debugging is supported. So you could have a dedicated x64 development machine and then remotely debug to a device that you have, say, on the desk. And that actually works really well, and it's almost like local, though it isn't exactly local debugging. If you do want to do local debugging, that works as well. You can use Visual Studio 2019, install it on the device, hit F5, there you go. You can do local debugging that way. Of course, Visual Studio Code, but I've already made 2 plugs to Visual Studio Code. I probably should stop there. If you're a fan of WinDBG, the Windows debugger instead, you can of course use that, depending on what you need it for. We recommend you use the debugger that matches the architecture of the process being debugged. So if you're using an ARM64, if you're debugging an ARM64 app, use the ARM64 WinDBG. And then if you're building a driver or otherwise need a kernel debugger, we do support KDNet over USB on these devices. Now, you do need a physical ARM64 device in order to do your local testing. But I do want to call out something that makes it a little bit easier to do that local testing in the insider builds. As of build 19559, we support running ARM64 VMs through Hyper-V on ARM64 client hardware. And so you can get the ARM64 VHDX file to bootstrap that VM from aka-ARM64VHDX. But having one of these VMs, of course, facilitates local testing, makes it easy to get a repeatable environment where you can clear it, start over, debug, installing the app, running the app, so on and so forth. It does make things easier to have that. but I do want to call out, since it is on 19559 or higher, it is not present on 19041, which is the build that most people have today. So you need to join the insiders to get access to it. However, since it is an insider feature, it's a great time to give it a try, and especially give feedback through Feedback Hub. If you hit issues, we want to know about it so that we can fix it, so that eventually it becomes, when it's released to everybody, more stable. It makes the platform better for everybody. And yes, if you're a sysinternals fan, you'll find that some of the big name tools are already built for ARM64, with more to come. Marc expressed his enthusiasm for ARM64 build 2019 on the right, using maybe not one of the devices we would have expected. But it definitely makes things easier to be able to use your favorite tools on ARM64, and as someone who uses ProcMod a lot, it's definitely very helpful. And so I want to say thank you for attending and for listening to me talk about Windows 10 on ARM. Now is really a great time to get started with Windows 10 on ARM. There's a whole range of devices out there, and so you can find one that appeals to you. I, of course, talked about the Galaxy Book S. It's what I'm using right now. I would hold it up to show you, but I don't want to risk stopping the presentation. But it really appeals to me, and it's what I've been using as my primary device since working from home started earlier this year. And so once you have one of these devices, it's a good time to try your app on ARM64. It might just work. And whether or not it works, or you need to add support for ARM64, we definitely want to encourage you to build ARM64 versions of your apps and get the best possible experience for your customers. And while you're doing that, I'd encourage you to check out our documentation at aka.ms/win10onARM. You can also, if you're curious, read about Aperture's new support for ARM64 at aka.ms/Aperture. And in general, if you have feedback, you can reach out to woafeedback@microsoft.com, WOA, of course, standing for Windows on ARM, and we'll be happy to hear from you. Obviously, we also have the Feedback Hub. Any feedback is welcome as you get started building for ARM. So thank you again, and best of luck as you build for ARM.